Thank you, and thanks a lot, Manfred, who will have already realised that I appropriated part of the title of this fine volume that he edited in 2012. So what I'm going to be talking about, I guess, is the simplest technological approach to what might be regarded as a true 3D display. And in Manfred's volume, there is an example of video being projected over a solid relief model. So I'm talking about solid physical models of fixed places, and there lies one of the constraints that Manfred already mentioned. But what I wanted to do over the last sort of 10 or 12 years really is to explore, as a geographer, how this simple technique could be used in various contexts that I'll describe in a bit. So clear linkages here to solid, if you like, but malleable models like the Illuminating Clay project, and like the BGS and many others, we built our own version of the augmented reality sandpit, which is extremely engaging and interactive, but not relevant when you want to try to convey information about a particular geographic location. So I'm talking about so a projection augmented model is, I guess, part of the mixed reality spectrum. So I'm just really talking about a geographically specific version of that technology, which, and I want today to run through some of my experiences in this. And I've picked on examples from around about 15 displays over the last sort of 10 years or so. So I want to talk about my experiences of the capabilities of this technique and some of the design heuristics that are emerging. If I had to try to pigeonhole these, it would be difficult into various applications. So this quite gaudy slide tries to show, I've tried to, but as you'll probably imagine, for example, a display that might be in a museum will have a function that is partly in informal education, as well as having some function more like a visitor center. So there's a lot of overlaps, but there are various contexts of use. So I've been really keen to try to explore lots of different examples and applications. I'll whiz through this because Manfred has really nicely already summarized the power of solid models. And from a landscape architecture and design point of view, this has often been referred to as a common language, which is why planners and landscape designers have used them for many years in a public consultation context. So, but I've been sold on this idea since I was a teenager. I used to make landscape models I realized after 4 years of going to model railway exhibitions at Skipton Town Hall that I didn't actually like railways or trains. I just liked landscape models. And so I started building them out of layers of various material. And we see all over the place, even today, models like this being installed, but some are still on display that have been around for a lot of years. And as William Wordsworth described in 1810, his encounter with this model in central Switzerland, he kind of summarized a lot of the power of physical models, that that this area, its hidden treasures and their bearings and relations to each other are thereby comprehended and understood at once. And I think that idea, that kind of natural frame of reference, is something that Manfred mentioned also, about the fact that you can effortlessly enjoy detail and then pull out to an overview. So you can benefit from high definition human vision in the center when you're looking closely, and then pull out and with your peripheral vision gain a really good understanding of the landscape as a whole. And this again is something that architectural model makers have been well aware of for many years. Again, in terms of our effortless encounters with physical models, which is something that I think Wordsworth was describing, free movement around the model does give a strong sense of three-dimensional structure, benefiting from that direct human binocular vision, high definition vision of a physical model. So eyes set wide apart relative to the model, it's going to give you a very strong sense of depth perception and able to judge relative heights and positions. And so I think that ability for the viewers to effortlessly experience lots of different oblique aerial perspectives is enhanced, particularly when the model is horizontal. If it's on the wall, as I've tried to show here, it's very difficult to put yourself into that perspective without having to twist your head and mentally rotate. So a model that is set horizontally allows the best experience, I think, and that's been the kind of model, if you like, of our approach to some of these displays. The first another fairly obvious thing, and again, I think Manfred's studies have pointed to this, in that they are very attractive and engaging, so people will be drawn to them. So one display here, which was actually a National Trust pub in the English Lake District, we had a challenge of positioning a display like this such that it was engaging but didn't get in the way. And so Keith Chevest and I had a small study looking at this display. So play this little bit of video. This is small, it's only about 6 across. Some friction include effects, cloud shadows, and moving vehicles I made over the model. Partly as a kind of an attractive mode, if you are interested in observing how people interacted, and then stuck with that model, learn about what the National Trust doing in the valley, which was the purpose of this particular study. So I want to spend a bit of time looking at some of the content issues, so issues about thinking about how we design content for this particular type of display. And I suppose one thing we need to think about firstly is what kind of information is going to be provided by the model itself, what is going to be provided through projection, and then what ancillary information would need to be shown, and the kind of dependencies within these, as you can imagine. This model here, for example, on the left, that was for the National Trust at Southall in Nottinghamshire, and we wanted to represent the Trent Valley, and the frame of reference for the Trent Valley was quite important to the visualizing the comings and goings at Southall Workhouse. And so actually a contoured model, so processing the digital terrain model to get a contoured representation, actually worked better. And so that, and in fact, for various reasons with the CNC milling machine at the time, I actually made this one out of layers of 3mm plywood. So returning to my teenage hobby there, which was quite nice. Whereas other models in urban areas can make use of other data sets, such as stereo aerial photography or drone imagery, but in this case it's LiDAR. Even then, though, you could imagine you could generalize in 3D printed form that that model. So we could have generalized the urban blocks. We could replace that the council house in Nottingham with some abstracted, slightly larger version of that. So a three-dimensional kind of symbol, if you like. So there are loads and loads of interesting options about designing the actual model itself, once you've decided what the frame of reference needs to be for the particular application. And then related to that, once you've done that, need to think about how you're going to highlight locations, because, and again, as Manfred has, I think, suggested already, projecting text labels onto a 3D object wouldn't necessarily work. So if we design maps differently so that you maybe highlight a location or use a lighting effect as best you can, and then have a context sensitive legend on a screen, or sometimes an audio stream above you, which relates to the ancillary information here. The fidelity of models is really important, I think. These shots are from an exhibition I was lucky enough to be able to put on about a historical relief model from 1875 in the English Lake District. So here I was trying to replicate from some original negative molds. I scanned them and digitally flipped them and CNC milled them, and then handcrafted the finish, as you can see here, to try to replicate what the original model would have looked like. I could only afford to do 3 or 4 of these tiles. It would have cost me about £80,000 in printing and fabrication costs, etc., to do the whole model. So we used a floor map to represent the size of it. But that was fascinating, and observations at this exhibition demonstrated that to get recognizable landscape features that people would enjoy discussing and touching and pointing at and would become a focus of their attention, then the fidelity, the detail of that model was important. We did have a less detailed model with projection on elsewhere, which was from scanned molds, which didn't have that fidelity that we might get from modern day data sources. So the fidelity of the actual physical surface, I think, is important. Related to that quite strongly, to get the best out of that physical representation, I think, is the attempt to try to match the projected imagery to the model. So what I've tended to do for almost all of these displays actually is to warp the imagery that's projected by modeling the display in 3 dimensions. So if you imagine just any kind of GIS based or any map that comes out of that's reference to that whole model object, basically texture map that object within the CAD model of the display, and then render images or videos from that from the perspective of the projector lens. So you get these warped images that then fit quite nicely onto the model. And as well as fitting nicely, this idea of rendering from a 3D CAD package opens up possibilities for creating ray traced lighting effects that can then be projected and give the kind of a bit of an impression of the model. The model I'm working with for Nottingham City gives that there's a light illuminating that model. You can so using it for good, I think quite an interesting design element. Animation is it can be really important, not just for attracting people to the display. I mean, this little example here, as well as some lighting effect, right, above the lake and things like that. Anything that's moving might add to the intrigue to get people across to the display. Maybe some members of the group will see that and drag the other members of the group across to look at it. Another thing about, just as an aside about animation, this is the slide used in school context, risk analysis, and with the coming of a risk model, JB was everything animated too smooth to show people looking at through observation discussion animation to an hour. Perhaps now and again, this quite stepped in that particular application here where we wanted to appreciate the area with the time where water side time, then it was something that we learnt from and carried on with that idea, thinking carefully about the temporal resolution. Quite often, this is from a display that I'm working at with the National Park Authority in the Lake District, trying to communicate what the World Heritage Site status means for the Lake District. And here, I think the idea that creating maps that are not necessarily going to be read for a long time, but are going to be just seen, I guess, and that idea of making a very clear figure over grounding from a cartographic perspective has been important to us, and that particularly with a solid relief model, I think there's a lot to distract the eye. So making sure that you try to reduce the interest in that very interesting physical object and draw people's attention very carefully to the bit of the model that you want to describe has been quite important. And that, as you can see, includes various lighting effects. This was an animation effect showing how where graphite was discovered and how that was ferried down to the Pencil Museum in Keswick. So it's telling a story about one particular aspect of this landscape. Shading and hill shading mentioned before in the first talk this session, and arguably you don't need well, you certainly don't need contours in this sense because you have a physical model, and arguably you'd say you don't need hill shading. But my experience has been that including a hill shading or even rendered shadowing effect whilst you're projecting onto this physical model does actually enhance the level of detail in the physical model, and it does actually work to good effect. So this example, sorry, apologies, quite small, but this is from a an example for the Environment Agency for Hebden Bridge, where the drone data was 3D printed. So you had very fine buildings represented in the model, but actually projecting a rendered shadow effect as well as hill shading effect on the terrain did actually exaggerate further the fidelity of the physical model. So obviously the projector I was using was only a normal full HD projector, but the resolution the human eye sees is higher because the 3D printed model was effectively at a higher resolution to the human eye. So again, sometimes where there's aerial imagery, you would choose the direction of shadows in that aerial imagery to determine where the hill shading or shadow comes from. So it doesn't matter whether it's from the north in this case, because you're looking at a model that's set horizontally and you're moving around it. So there are other considerations for determining the design there. I also used, oops, that's disappeared. Also used in one display to try to mimic mountain building over the model in a display that was telling the landscape history of the Lake District. Actually try to obscure everything about the modern day terrain by projecting a series of images like this, which were rendering the shadowing effect of a bulging mountain uplift, which sounds a bit odd, and that's something that's under development, but it does seem to be working to give quite a crude idea that the physical model is rising up. But I guess here we're talking about where you're hitting some of the obvious limitations of a technique which uses a fixed display. Oh, there we go. Sorry, slight issue with the. I think it's my manual dexterity actually. There we go. So in terms of symbols, thank you. So symbols get very disrupted when projected onto certain types of physical models. So trying to avoid pictorial symbols and text strings and have different simple symbols or lighting effects with a context sensitive legend on the screen has been the way to go. And that just popped up and disappeared. I was just saying that projecting historical maps onto detailed models of urban areas doesn't always work too well either, because the cartographic portrayal gets very disrupted by the modern day physical model. Enhanced spatial text is more you are happy to that kind of fascination that visitors have with historic been an important model. This is the model the surface will oriented mold people they are to that museum in late Victorian times. I think another restriction clearly of a fixed model is representing things that are beyond the model. This display of Skipton, we were lucky enough that there was some interest in the catchment management to the north. So here I tried the idea of effectively a digital diorama by making the monitor butt up to the screen and kind of match. And so that was used quite effectively there, so we could animate some of the things that were happening related to flood risk upstream. In this particular case, here the screen was used, so you pull away from the diorama effects, try this font. So this was Keswick model display in sort of related to the large cat that into town. And designs about using these two kind of displays together.
3 minutes left,
this
Gary.
was an interesting project in that we
only 3 minutes left, Gary.
This model was some such a area as we present perfect. So 10 minutes left. Just quickly then, we used projected maps of the Earth onto the Mars models, and it's always Wales here, isn't it? That we could show pupils that this crater was half the size of Wales, or in this case, Olympus Mons was almost as big as France. So trying to convey scale and geomorphology was of interest here. I'll start speeding up a bit if that's okay. So other capabilities then, I think linking displays to existing media has been of interest, and so a lot of the displays with from wherever they are and take a bit of with them. Or Samo, the example campaign related to walks. Ongoing work, and this is something I'm picking up after lockdown now, a model that I've got in Keswick Museum. I want to make that more explicit in the way that we connect objects on display into the narrative of that display, so that it places those physical objects into the context of land history. Storytelling in schools, I think an idea of kinesthetic learning has been with people our extended to their projected content, and that may affect how I've but that's self for visualizing a very large type in a display making for related to the world. So that worked very well. Spatial knowledge acquisition, just wrapping up for the last minute or so. This model, so this vision syntax to why, so this is mid one student is by building and this has become for our states in terms of trying to spatialize some of that hasn't explicitly met before, really. So British wider audience, for instance, using displays in schools quite a lot for supporting lessons, and this relates to the power for discussion and decision making. I think, which again, this is the display I mentioned for the Environment Agency at Hebden Bridge with the diorama effect. That's going to be used for public consultation. Finally, the last 30 seconds, just to say that you'll have noticed that the model, because I haven't mentioned it, is not interactive to touch. It doesn't give feedback if the user touches it, but as this dirt map on the model of the Langdale model suggests, people do like to touch models centered on the UI here location, but also just this stroking effect, this reassuring stroking effect, which we've observed in other displays through video observation. We demonstrated through what interaction was understood. We've created an interactive here. I'm watching here. I'm pressing the buttons, can use a print, and we expect that will follow that up. So to try around interaction work. The technologies for the model responsive to touch have been beyond scope of what we've been interested in. Manfred probably has a good idea here, but one of our PhD students has been using the Kinect to detect when the finger disappears into the model. So I'll leave it there on this summary slide. Apologies, I've gone over by a few minutes.
It's all right, Gary, that's fine.
So apologies for that. But I'll just leave it there with a summary slide, and I'll sorry about that.
That's okay. That's great. So we don't have time for any questions and things. There was a bit of buffering going on with the video. So hopefully we can share the videos with us later and we can do that piece again if we need to.